How does a PLC read a temperature it can actually trust? Not roughly, to a fraction of a degree in a hot, electrically noisy plant. Very often the answer is a small sensor called a Pt100 RTD. You will find it on heat exchangers, furnaces, tanks, and motor windings everywhere in industry. So what is it, and why is it the default for accurate temperature? In this video, I will explain what an RTD is and what the name Pt100 actually means. Then the lead wire problem, and why you see 2-wire, 3-wire, and 4-wire versions. How it compares to a thermocouple, and how it finally reaches your PLC. Let us start with the principle. Quick note before we dig in. This is from PLC Simulator, where you can practice scaling a temperature sensor and the rest of this video free, right in your browser. No install, no hardware. The link is in the description. Click the link in the description to try it free. Now back to the sensor. Start with the idea. RTD stands for resistance temperature detector. It is a sensor whose electrical resistance changes with temperature. Heat it up, and the resistance rises. Cool it down, and the resistance drops. And it does that in a clean, predictable way. So if you can measure the resistance, you can work out the temperature. The Pt100 is the most common type. The point is platinum, and the 100 is the key number. It reads exactly 100 ohms at 0 degrees Celsius. Why platinum? Because it is extremely stable and very linear. The resistance to temperature curve is almost a straight line, and it barely drifts over years of service. That is what makes a Pt100 accurate and repeatable, where a cheaper sensor would wander. Now the catch. The PLC measures resistance, but the wires running out to the sensor have resistance too. And that lead resistance gets added straight onto the reading. On a long cable run, that error can be real degrees. This is why RTDs come in 2, 3, and 4-wire versions. A 2-wire RTD is the simplest. The lead resistance lands directly in the measurement, so is only for short runs where accuracy does not matter much. A 3-wire RTD adds a 3rd wire, so the input card can measure the lead resistance and subtract it. That is the workhorse, by far the most common in industry. A 4-wire RTD goes all the way. It separates the wires that carry current from the wires that sense voltage, so lead resistance cancels out completely. It is the most accurate, and you see it in labs and calibration. So how does an RTD compare to the other big temperature sensor, the thermocouple? They solve the same job in opposite ways. An RTD is more accurate, more stable, and easier to read, but is limited to roughly minus 200 up to 600 degrees Celsius, costs more, and respond a little slower. A thermocouple is the opposite. It covers a huge range, well over 1,000 degrees. It is rugged, fast, and cheap, but it is less accurate and it drifts more over time. So the rule of thumb is simple. Need accuracy and stability in a moderate range? Reach for a Pt100 RTD. Need extreme temperatures or rugged and cheap? A thermocouple. Picking between them is one of the most common decisions in instrumentation. Finally, how does the reading get into the PLC? 2 common paths. The first is a dedicated RTD input card. You wire the RTD straight to it and tell it the type and the wiring. The card does the resistance measurement and the lead compensation for you. The second is a temperature transmitter. The transmitter sits at the sensor, reads the RTD, and converts the temperature into a clean 4 to 20 milliamp signal. Then any ordinary analog input can read it, and the long run to the panel stays immune to noise. You then scale that 4 to 20 milliamp signal into engineering units in the PLC. I have separate videos on reading an analog input and testing a 4 to 20 milliamp loop. They are linked below. So here's what to walk away with. An RTD is a resistance temperature detector. Its resistance rises predictably with heat. A Pt100 is the common one, platinum, 100 ohms at 0 degrees, very linear and very accurate. Watch the lead wires. 3-wire is the everyday standard. 4-wire is the lab-grade option. Pick an RTD for accuracy and stability, a thermocouple for extreme range, and it reaches the PLC through an RTD card or a 4 to 20 milliamp transmitter. Get that, and every temperature loop on the plant makes sense. Now, go make it concrete. If you want to practice scaling a temperature sensor hands-on, click the link in the description to start free at plcsimulationsoftware.com. No hardware, no install. Subscribe. New video every Tuesday. See you in the next one.